Hi, this is Karen O'Brien, and we are going to put together a storm drain system, but I'm going to kind of give you like just an idea of why we're doing this, what the purpose of this is. So let's say that I have this project. It's called Upper East Fork Cave Creek. It's like the whole project of this, but we made that project with, I think it's like storm and sanitary analysis, and back before the plugin and back before this was even a thing. So we made that project. So let's say I wanted to get that project and I wanted to modify it or add some new development to it, or maybe just do something different to it. But I wanted to work with the storm drain, but I don't have that storm drain system. So this video is going to show you how to do that, how to get that data back. So I'm gonna, we're gonna practice on this self-help kit. So this is the end product where we want to fill these tables, we want to build these 3 layers, and we want to fill all of this data up and from a project that already exists. Okay, so let's see what we have. First of all, let's just close this out and let's go to the project folder. Let's see, QGIS tutorials, and I've been working on this in here. And let's just get rid of these guys, okay? We don't need them. We're going to rebuild this entire system. Also, I don't need the export files because, again, we're going to rebuild that entire system. The import files are here. So this is the Flow2D project along with the storm drain. What's missing? Spatially variable rainfall, because it gets really big and it's a pain to import. And it's really easy to rebuild it. So I'm not going to import rainfall. I'm also not going to import infiltration. Again, it gets really big and really complex, and there's no reason to import it unless you're going to modify it. And I'm not going to modify it, so I'm not going to import it. So I also turned off the rainfall and infiltration switches here. So what are we going to import? We are going to import the ARFs, spatially variable buildings, the channels, the culverts, the boundary conditions, inflow and outflow, and the walls. That's the levees, the walls. Roughness, obviously. We're going to import the, these are the data files that connect the Flow2D grid to the storm drain system. This is like a standard INP file that can open, that you could use in EPA SWMM GUI. So it's like your standard INP file. And of course, that's our channel. This is our grid, and this is our roughness. Okay, so let's get into it. Let's start by just loading QGIS and setting up a new project. Let's also make a backup folder. I'm gonna pop this in the backup folder just to get it out of our way. And all right, we do not need any of this stuff. So let's go clean map, set the coordinate system to our project coordinate system. And what we need to do is build an empty geo package. So Flow2D settings, create, and let's call this storm drain import. Oops, that's not how you spell it. We'll just wait for that to build the table, set that to the coordinate system. This is going super fast because I've already done this twice this morning. So it might take a bit longer on your end to kind of organize and initialize all of that information. Click OK, and the whole project loads. Now we want to import the project with the storm drain in it, okay? That's this guy right here, import DAT files. Let's stop calling those GDS files, import the DAT files. And here's our import DAT files. Let's grab the cont.dat. And of course, the bigger the project, the longer this is going to take. That's why I took out infiltration and spatially variable rainfall. And then you just grab everything, click OK. So once that's finished importing, it's going to give us some messages. First message, would you like to create these 2 or fill these 2 fields in the grid layer? Yes. The reason you want to fill those two fields is because they work with NumPy and help speed up some of the things that the plugin does. The next message is, to complete the storm drain functionality, the computational domain and storm drain conversion must be done using conversion from schema layers to user layers. I'm going to show you this process. So you convert, let's just look at it. And then of course, if you want to do, schematize your boundary conditions, you can do that too, but I don't recommend it. It's not necessary because we're not going to edit our boundary conditions. So click OK. And here is the converter tool right here. And so we definitely want the computational domain. And I don't actually need the storm drains because they're not really right at this point. But I'm going to do this anyway to show you why. Don't ever do channels. Don't do boundary conditions unless you plan on editing them. And don't do levees because it will just give you these little fractionated little levee segments, not your original levee lines. If you wanted to rebuild this project, you might want to go grab those original levee lines and get them and put them back in from the other project. But this is, the levees are good to have in here because, okay, so that said that the conversion was complete and now you need to import the INP. So we'll do that in a second. But the reason we wanted these levees and buildings in here is because we want to make sure that they don't interfere with any of our storm drain inlets. So that's why I always kind of use those 3 files together. Walls, in this case for Maricopa County, Pima County. Sometimes they do this in Nevada, and a few other counties in Arizona do these walls. Okay, let's see. So what happened here? When I told it to convert the storm drain, what it did is it copied the data from these 2 tables into this table. Okay, so let's check this out. Let's see what's in these. One, right click, open attribute table. It has the data that is written to the swimflow.dat file. Let's open up the swimflow.dat file so you see what I mean. Okay, so D means that's written to the file. Grid element number. This is the name or swim_IDEN. Keep that in mind. Inflow type. This is the length. So this is a curb. Type 2 is a curb. So that's the length of the curb opening. 3 foot, 6 foot, 10 foot, 17, 26. 1 is the, let's see, that's the width. So that's probably related to like the sag or the width, or if this is a type 2, maybe it's a curb and gutter, but with a grate. So that might be the width of that. And this is the curb opening for type 2. Weir coefficient for the flow over the edge of the curb. That's a feature switch. It only gets set for type 4s. And this is a curb height, which we're not using in this project. So if you want to learn more about these, please review the storm drain guidelines document that's in our documentation folder. I'm going to close this and close this. Outfalls, same thing. Open. This is from the SWMM. Let's take a quick look at it. Okay, SWMM, the name, grid element number, and whether or not it allows flow back to flow 2D. So this is really Q allow. This should probably be named allow Q because it allows flow water back to the flow 2D grid system. If it's turned off, it turns that outfall into a sink. If it's turned on, it takes the water from that outfall and it exchanges it with the grid system depending on the head on the flow 2D system versus the head in the storm drain system, okay? And we didn't get any information for conduits, okay? So that's the problem with converting this data into this data. So this file is just a combination of these 2 and a couple other links to these other tables. So we're going to look more into that later. All right, so that didn't really work for a couple of reasons. I'm going to show you why. Now it told me to finish this system off by importing the SWMM INP. So let me go ahead and import the SWMM INP. Be careful when you import or export a SWM INP. It's always going to point you back to the SWM path, and the SWM path is always the last thing that you did with import or export SWM. So be careful with that. So we want to import this time. And it says there's already a storm drain data in the user layers. Would you like to keep it and complete it with the data taken from the INP file? Or would you prefer to erase it and create a new storm drain? So first I'm going to keep it because I want to show you why that's what you don't want to do. And so first off, it says that there are 198 nodes. So that right there is an indication that something's wrong, because I think I have like 248 nodes, and it's telling me that there are 271 conduits. So the conduits came in okay, but the nodes did not come in okay, right? Why? Because the nodes are not attached to the conduits, all right? So that is an issue. Okay, so let's see. And another thing that's wrong is that the junctions did not come in. Only thing that came in were the inlets. So that just messed the entire system up. It's not going to work. So let's do this again. Import the INP. This time we don't have to worry about the path because the last thing we did was import. And this time we're going to do create new. Now, this is also kind of wrong, but it's a lot closer to being right. So now I have the 284 nodes, and they are in the right spot. You can see they're in the right spot. So here's my inlets. Here, look, if you look at this, you've got, watch right here in the center of this while I turn that on. See, that is a junction, meaning that it does not connect to the surface. These little blue guys are inlets, meaning that they do connect to the surface. Inlets are also tied to grid element nodes. That's why these guys, SD inlets, are centered on the center of the node, because they're more tied to the grid element node, and these guys, the storm drain nodes, are tied to the storm drain system. But and then let's go ahead and look at one more. Okay, here we go. And then there are the outfalls, let's call those outfalls, not outlets, okay? And they are the little orange guys. And oops, I'm sorry. And again, the little orange guys also have their flow2D counterpart. This is the swimflow.dat file, and again, it is always tied to the centroid of the grid element. So what we need to do, so what happened when we did this is that the data in these tables, the inlets and outlets, became disconnected. So this data became disconnected from the data that's in here, because this now comes only from the INP. So if I open this, you can see that the swim length, swim width, swim height, all that stuff is missing. My curve height, I didn't use it anyway, it's missing. Also, my inlet types are all set to 1. And we know that that's not right. And my outfalls. So my outfalls are also missing information. They are missing the allow discharge. See, they're all set to false, and these should all be set to true. Okay, so let's try that again. Well, we're not going to try it again. What we're going to do is, like, the storm drain is in place. It's in the correct place. So now what we want to do is save the project. Oh my goodness, so annoying. It always does. It always goes back to like the last place you were working. Okay, let's save the project. And let's call this storm drain import. And that's going to be a QGIS file. And then let's close it. So now you can see here that we have this is our project with our storm drain in. Let's zip it. Okay, let's zip it. And let's call it storm drain import no no swim flow tables. So that'll just indicate that the storm drain import was complete, but there's no swim flow tables yet. We're going to make that now. And the reason I saved it is because I'm about to use a database browser to modify and table join that and fill that missing data. So let's grab that. First of all, let me make sure that I took care of everything in my list here. So we have import the INP and review the keep existing, import the INP again and review the keep new, review the tables. Open the database, go over the commands and go over the tables. Okay, let's start the database. So first of all, let's get into the commands first. I have to load those. And what I have done is I have saved these commands here to a text file right here. And now I'm going to import those into here. So let's just open file. You know what? I'm so tired of moving to different paths. Let's just copy the path and we can just paste the path in the correct location and click open. And then what you see here is the commands for what we're going to do. Now I'm going to come over here to the tables to show you. So there's a lot of tables in a Flow2D geo package. So let's just use the S key to take us down to the storm drain table. And we have swim nodes or swim flow is what we're looking for. So here's the swim flow. That is the swimflow.dat file. That's the swimflow.dat file. We also need the swimflow RT. That's the rating table for our one type 4. And we need the swim out F. That is the swim out f.dat file. I just showed you those 3 files, or those 2 files right here, right? That's these 3 files: swim, flow, swim RT, swimflow RT, and swim out F. This is the data that joins to those tables when we export the project or import the project. What we need to do is get the data from these tables into our user swim nodes. Our user swim nodes is right here. As you can see, we're going to take a look at some of these. So we are going to update the table user swim nodes from the in type. That's the in type right here. Oh, my control key doesn't work here. Oh, that's escape. Here's your in type. We want to set this variable in type, select in type from the swim flow. So you can see this one also has an in type right here from SwimFlow where the user swim node name equals the SwimFlow node identity. So the swim identity and the swim and the name, those 2 fields match each other. So wherever those 2 fields match each other, we're going to copy the identity from this table, we're going to copy the type from this table into this table. Okay, so let's just review all of these and make sure we have them set up right. So this one is type, swim identity. So we want to look at all these are the same. Then everything down to 7 will be swim flow. So let's make sure all those say swim flow. And user swim nodes dot name equals swim ident. So we want all these to be the same. User swim nodes to swim ident, user swim nodes to swim flow ident, user swim nodes dot name to swim flow ident to swim flow dot swim ident. You know, that's what we want these 2 all to be the same for those 7 columns. And those all look good. Okay. Now we also need to call the swim flow allow discharge. So it says to select. I don't think this one's right. And I don't even think it's in the right spot, to be honest with you, but let's see where it is. I think this is assigned to the wrong, I believe when we imported this that it assigned it to Flapgate instead of allow discharge for some reason. So let's go back and let's browse our data real quick and see where this is at. I don't know, that one wasn't Flapgate. Let's just see where that data is at. So we need to go to the swim out F, let's go S. swim out F. And yeah, okay, so it's in the outflow. So it's in the swim out F table where the name equals the name equals the name, and we want to use the outflow switch. So that's not actually right. That should be called allow Q. But it's still there, so let's use it. So let's go here and let's just read it. Set the swim allow discharge, select outflow from the swim out F where user swim nodes dot name equals swim out F dot name. Okay, so actually it was set up correctly to do that one. So it is the feature switch that's wrong. Oh, the feature switch isn't in here. No wonder why it didn't work. Okay, so let's put the feature switch in. So the feature is a type 4. So that means that shift home, copy, and enter paste. Okay, so the feature, oh no, it is there. It's right there. Okay, swim feature is there. Okay, so let's just delete that. That's fine. Okay, so swim feature is here. So in the user swim nodes, the swim feature equals, okay, swim feature from swim flow where user swim nodes.name equals swim flow.ident. Okay, so here's the one that's messed up. So this, let's go to swim flow and let's go to feature. So see the swim feature, let's just see if I filter that by 1, nothing is there. But if I filter flapgate by 1, then it has something there, but that's actually wrong, okay? So it's not a flapgate, it's a feature. So really we need that to be here because inlets do not have flapgates, right? Inlets and junctions don't have flapgates. Okay, and then we'll close that filter. And now that data has been modified and corrected. So the next time we open this in QGIS, that modification and correction will be in place. So be careful if you're using type 4 head wall inlets, that be careful about that being assigned to the flapgate because that's not correct. I'll have to have that fixed on my import statement. Okay, swim flow. What do we got? Swim flow, swim flow, swim flow. Okay, so I fixed it there. So I do not have to fix the statement. Now I could have fixed it there, but if I had a bunch of them, maybe I would just want to say, we want to maybe select, and I might want to just name this flapgate because that way I wouldn't have to worry about it, you know. But what I want to do is I want to get it right and I want to fix that so that it's imported in the correct location. All right, next is run the SQL. So you run it and it says that how many seconds it took, how many rows were affected, and what it did. And let's say you mess something up, and let's just call this FFF, and let's just click run. And you can see right away that line 9, or like at line 9, I don't know why that's line 10, but whatever. You can see right away that it highlights the problem and you can fix it. Or if something doesn't work, and when you're reviewing your tables, you'll know right away because the data will still be missing or it'll be totally wrong. Okay, so let's take a quick look at it. Browse the data. Now we want to go to, let's go right, user, this one right here. And we will see now that this data, let's see, it's right here, has been imported, okay? Let's see, what did we get? We should get the type, wherever the type is. The type is back here. We got the type, and we got the geometry, and we got the feature switch. See, I only have one type 4, so I can see that my feature switch is here. And the curve height we didn't use. We didn't have any clogging factors, so none of that was filled, none of that. And the allowed discharge, let's filter that by true. Nope, let's filter that by 1. The allowed discharge can be 1, 0, or yes or no, or true or false. It's a Boolean, so it can be any of those. We got that, and we got the outflow, the That was, what the heck was that? Oh, I don't think it's anything, to be honest with you. I think it's I think that's supposed to represent like a steady outflow discharge is what that's supposed to represent. And it's just not connected correctly, maybe. Well, we're not using any of them. And then these are all derived. Okay, so let's close it out. But first we need to write the changes. So we write the changes and then we close it out because we're done with it. Go back into QGIS and reload the project. Oh, let's take a quick look at our project. And you can see here that our 105, 106, so that data was written and it's a little bit bigger. It used to be like 17.2 something. So let's go ahead and open that back up. Ooh, I should have opened this before I showed you that. We give us time to open it. And we're done with this folder. And now while we're doing that, let's go ahead and get inside our input file. And that way the next thing that we do, actually that should be our export folder. The next thing we do is going to be oh wait, I lied. That's not what we're going to be doing next. The next thing we're going to be doing is to converting our storm drain layers back into usable, functional external data sets. So you'll understand why we're doing this once we get this loaded back up. So this is storm drain import. Right. Now it says reload the project, go over the tables, create the new layers, delete opposite components from the nodes and outfalls. And then this is go over size. Okay, I think I know what that means. All right, let's try this. So what we need is to take the data from these from these layers and get it into external layers, right? Because if you've ever looked at documentation, if you've ever looked at like how we create a storm file, like you start with these three layers, right? Junctions, outfalls, conduits. You start with those three layers. So if you do any modification to this data, the modifications need to be done here, not in, sorry, let me get rid of this for a sec, not in these layers. The modification needs to be done in these layers. Let me see if I can open that in a new tab. See, inlets, junctions, outfalls, and conduits. And the first thing you do in lesson 3 is you import those. But what we're doing is we're rebuilding those. All right, so conduits, pumps, orifice, and weirs is super duper duper easy. You just right click and export, save features as. We want to save it as a geo package. I'm going to show you why right now. So let's call this conduit or conduits, whatever, it doesn't matter. Make sure that your coordinate system is the same. Make sure this says geo package and everything else, nothing changes. Click OK. Now, I want to show you, now I want to do the exact same thing, but this time I'm going to use a shape file, show you why not to use a shape file, okay? Right click, export, save features as. This time we're going to go to a shape file. Same thing, we're going to go here, we're going to go this conduit, but I'm going to call it conduit shapefile. Doesn't matter if the name is weird or whatever. And so first thing that's wrong about using the conduit shapefile is that the export process of QGIS to shapefile only allows a 10 characters in the field name. I don't know how to not do that. I don't know how to not get that. So rather than trying to figure that out with some kind of script or whatever, I'm just going to get rid of that, remove that, and just use the geo package instead. Okay, see, because all the layers have the perfect length, all the fields, excuse me, let's make sure that that's not sorted, have the perfect length of name, and it's very easy to identify what field we're looking at, okay? Next is, ooh, these things are annoying. Oh, next is the size of that geo package. All right, look at the size of this. That's, hang on a sec, 524 kilobytes compared to 172 kilobytes. So, and you only get one file. You don't have one file. You don't have this whole mess of files. So very nice and easy way to, take care of manage your data in polyline data. There's probably a way you can do all that into a single geo package, but I'm not quite certain how that works. So now we need to do the same thing for the nodes. Now we don't have any pumps, orifice, or weir, so I'm going to ignore those and skip those. But we need to do the same thing for the nodes, except we have inlets, junctions, and outlets in this. We need to do it twice, and then we need to separate the two. Okay, so let's do this. Export, save features as. Again, put that to a geo package and name it. We'll start with outfalls because it's a little easier. Now, what don't we need? We don't need the grid element. We don't need SD type. We don't need inflow type because these are outfalls. We don't need external inflow because that's for inlets. We don't need the junction invert elevation because we are doing outfalls. Nope, 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 nope. Don't need any of those. They all go to inlets, not outfalls. Now, we do need the outfall invert, outfall type. We don't have a title curve or a time series attached to our inlet or our outfall, so I'm going to turn these both off. There is a flap gate field, but we're not using any flap gates. But if you did want to put a flap gate in, let's just go ahead and leave that on. Okay, the next, these are all related to inlets. So let's just check them all off. And we don't have any clogging. We do have allow discharge. I don't have a fixed stage for any of my outfalls, but if I had a fixed stage for my outfalls, it would go into this field. It's just named wrong. I don't have any rating tables attached to my outfalls. Okay, outflow. I think this is like giving you the opportunity to set a fixed discharge to an outfall, or maybe a fixed discharge to an inlet. I honestly don't know what this variable, oh no, it's a switch. I have no freaking clue what this variable does. I think maybe it's allow discharge, but just in the wrong place or at the wrong name. So either way, we don't need it. So we don't, and these are all derived, so we don't need any of these. They're all derived from the QGIS plugin, and you can keep notes. Click OK. Let's move this up here. But look, what's the problem with this? It's got all those inlets in there too. So right click, open attribute table, select everything that doesn't start with a J or I, or everything that's not an outfall. That's why I always start my outfalls with an O, just to make them easier to track. So we're going to select all those features that are not outfalls, edit, delete, save, close. Now, those are only outfalls. Watch what happens when I turn that on and off. Nothing is happening except down here. Okay, next one is do the exact same thing, except we're going to isolate the storm drain inlets and junctions. Okay, out. Oh, I'm sorry, I didn't mean to do that. Export, save features as. This becomes, let's call this inlet dash junction, just something easy. And do not need the grid element, do not need this type, that's for QGIS. Yes, name, yes, we do need the inlet type. All right, external inflow. I don't have any external inflow, so I'm going to turn that off. Invert elevation, yes. Maximum depth, yes. I don't have any initial depths or surcharge depths or ponded areas assigned to these nodes, so I'm going to turn all of those off. If you had those, keep them on. Outfall invert, nope, don't need anything related to the outfall, so no tidal curves. I don't have any time series associated with any of my inlets, so I can take that off. There's no flap gates. Inlets do not get flap gates. Junctions do not get flap gates. Only outfalls and conduits. You need all of these because that's what goes into swimflow.dat. I don't have a clogging factor, but if I had a clogging factor, I would leave those two checked. This is for outfalls. I think that's for outfalls. These two, I'm going to keep it, but I don't think it's going to use it. I think it's going to automatically connect it a different way. And the rest of these are derived by the plugins. Let's make sure we uncheck all of those. Okay. 1, 2, 3, 4, 5, because it'll rebuild them regardless of whether or not we have them. And you can keep the notes. Okay. And now, of course, keep your eyes down here on those outfalls, okay? Watch what happens. See, we have everything. So we're going to do the exact opposite of what we just did. Open the attribute table. This time we are going to Control End, grab the lines that are associated with the outfalls, edit, delete, save, turn off the editor, and we are done. Okay, so these guys are done. And let's go ahead and take this entire group, right-click G, we'll group it to storm drain. You can do the same thing now with your boundary conditions, right-click G, boundary. Sorry, that Below 2D plugin can't do this for you. Right-click G, boundary, nope, sorry, channel. And then a lot of the rest of these we don't really have or are not using. So things that we're not planning on using, I will right-click G and say not used. And if, of course, if I have something in there accidentally that I want to use, I might pull it out when I need it, as needed, enter. And see how that just cleans your map up nice and easy. You can also put your comp domain up here if you want. It's not like that, you can't. Okay. Because your comp domain is, whenever you go to like recenter or zoom to extent, your comp domain is what you're zooming to. All righty, what do we got here? So now we are ready to, let's see, we are ready to save the project and continue on with our system. So the next step will be to, let's take a look at our storm drain layers. So now if you wanted to, now why did we do this, right? The objective of this discussion, or excuse me, of this tutorial is to show you, now if I wanted to add something to this map, I add it to these layers, okay? So let's just put some fake data in here to show you how easy this is. All right, let's go inlet, edit, add, just grab in any grid element you want to put that to. And then of course you would fill out this data, you know, fill out this data with the correct data. And then you click OK. Then do the same thing with your outfalls. Let's say we wanted to join that inlet to the channel. Fill out the data, click OK, and conduit, final layer, grab add a line feature, turn on the snapping tool. If you can't find it, right-click the toolbar area, go down to the toolbar section, find the S's, and make sure snapping tool is checked. Do not snap to the channel. Do not snap to the corner of the grid. Do not snap to any other feature. You want to snap from this feature, and I'm zooming with my wheel, to this feature, and then right-click and enter all the data and click OK. All right, and then check this out. I'm going to go here and I'm going to click select the components from the shapefile. I'm going to click assign selected fields, and you're going to see that we now have, whoops, sorry, wait a second. Oh, hang on a sec, let's try that again. Did I not get that? Yeah, I get that. Let's save. Oh wait, I don't want to save that, dang it. All right. Hang on, let's make, oh, conduits, sorry. For whatever reason, I must have storm drain conduits. No, it's this guy. Oh, I see. For whatever reason, I didn't go over this anyway, so this is a good time for us to go over this. First of all, let me get out of here and let me correct my mistake, because I didn't mean to. I don't want to save that. I want these to be in editing mode. I don't want to save this because I don't want this. I don't really want these in here. I'm just showing you how well they work. So fill in the data, click OK. Now, the next step will be to select the components from shapefiles. So that's going to move the data from these shapefiles into these layers. Okay, so we're going to select a component from shapefiles. We go inlet junctions, name goes to the name, inlet type goes to the inlet type. So this is all the fields are all from here, pointing back to here. We didn't use initial depth. We didn't use surcharge depth. We didn't use clogging factor. This one is actually empty, so we don't have to use that one either. Outfalls, same thing, name, invert elevation, whether or not it has a flap gate, allow discharge, outfall type, didn't use these. Conduits, we have to set these up. Name, from inlet, that's the node it's connected to. From outlet, that's the node it's connected to downstream. This is upstream, this is the downstream. Offset, upstream offset, downstream offset. Shape, where is the shape? I always lose it. Barrels. Maximum depth, that's right here. So that's the cross-section maximum depth in feet. That could be rectangular or circular. It's going to be in feet. Geometry 2, which again, we didn't really set geometry, so we could leave those blank. So we don't have to use those because we didn't use anything but circular geometry. So we can leave those blank. Length. And you want the length to come from SWM, not from the map, okay? Where is that length? Oh, here it is. You want the length to come from the as-built, not the map. Mannings, unless it's less than 20 feet, or 30 feet, which is our grid element size. The short pipes in Flow 2D does not like short pipes, so don't set your pipe length less than your grid element width, okay? Any short pipe goes to your pipe length. We didn't have an initial flow. We didn't have a max flow. We didn't have any entry coefficients, and we didn't have any flap gates. But those things are here, but they don't have any data in them. There's no sense in filling empty data. And then we click Assign Selected Fields. And what happens is, is that the data gets written into these layers. And it overwrites the data that's in these layers. So in this case, we only had conduits and nodes. And it's overwritten. So see, and now what happens if I no longer want that data? Let's take these three, right-click, toggle the editing, and discard all the changes because we don't actually want that data. And let's select the components again. So you see how easy it is to add and remove features from these three layers. Of course, you had pumps and orifice and weirs, you'd put those into their own layers. But you see how easy it is to add and remove features from those three layers. Then once you do that, you hit Assign the Conduits, and that is going to overwrite those inlet and outlet node names from the nearest neighbor to the upstream node and the downstream node. It's going to fill in that data automatically. So you don't have to worry about getting those node names exactly perfect because it's going to do it for you. And then the table was already in the data because we imported it, so that's already automatically connected. So we hit this schematize button, and that will kind of complete everything down here. If anything, sorry, wrong one. That will complete everything in here. So if we added any extra data, it would fill out this data here and fill out the data in these tables. Table data is typically automated. Table modifications are typically automated, but like copying the inlets into the storm drain features or copying the outfalls into the storm drain features. If those change, you need to hit the schematize button again. Like if you modify the position of those, you need to hit that schematize button again. For example, let's just move one. Let's just move a couple of these. So let's move this one here. And whoops, I don't want escape. And this one, oh, for crying out loud, escape. If you pick something up and you mess it up, just escape or Control Z. What I'm trying to do is get on the junction. Pick it up, click it to pick it up, click it to drop it. Make sure the snapping is on. Now let's check this out. See, here's the old one. I'm not going to save this because I don't want to, I don't want to keep that data, but I am going to commit it. I'm going to commit it to the map. See, the storm drain layer is moved, but check it. That guy's still there. Watch. Schematize. The schema data moved. So that's kind of like the power of this system. And again, I don't want to keep those, so I'm going to right click, toggle editing, discard, same thing. Assign selected and schematize. Okay, see how that fixed it? So that's why you need these. You cannot do that moving nodes and schematizing in these layers. You can't do that in these layers. It doesn't work. It's like it's just not functional. You can't do that in these layers. And you can't add data to these layers like you can these layers. You can't delete and add stuff very easily to these layers, but you can do everything here. Next is okay, so we showed you how to modify that. Let's show you how to export it. All right, so export. So we need export the GDS files. And remember, I deleted all the data out of that export folder. And we just want the storm drain. So I'm going to select the folder. Now I want you to pay very close attention to the paths and the messages. So I'm going to select the folder. I just want the storm drain because I'm just going to compare the two groups of files to each other in a compare tool. So it says, did you schematize the storm drain? Do you want to export the storm drain files? Yep, I schematized it. So click yes. And now look, it moved us back to the wrong path. So be careful about that. Remember these two buttons in the import export INP is linked to the same path for import and export. So it's a little wonky. We want to move that back to this path, select that folder. This will now write the control data for the INP. Click OK, click OK. That's just telling us what it wrote to the data files. And then we go here and we see that our INP data, let's get rid of these two. We don't need these two. INP data, SwimFlow RT, SwimFlow, OutF are there. Now, let's go ahead and close QGIS. And again, why did I just close it? Because I want to make a backup. Right click, 7-zip, add to 7Z. And then I want 7Z makes these really small. And then I want to name this storm drain import. Let's see, external layers. Okay. Pop that into my backup folder. Also want to back up these guys. Right click, 7-zip, and look, 32K. So excellent compression on GeoPackage files, way better than GeoPackage files compress way better than shapefiles. All right, what do we got here? This is storm drain layers. Let's call this original configuration. Okay, and then we will cut that to our backup folder. And now we can add or take away or simplify or modify or add some development, whatever, to our project if we want to do that. What else? Oh, export data. Okay, check this out. Now we're going to export data up here. Oh, no, I didn't want to do that. Sorry, I didn't mean to do that. I meant to, wait, I know what I wanted to do. Open in a new window, import data up here, and export data down here. And we are going to look at the INP file first. And we're going to, so this is our import INP file. You can see it says import right there. And here's our export INP file. And if you would like to use the comparison tool in Notepad++, you need a plugin. So you go to plugins, plugin admin, and if you don't have admin rights, you probably aren't going to be able to do this. And then go to, well, I'll just search compare. And you see here, it's got another one, but I already have it. So installed, and you can see here that I can use it. I think you can also update it. I think it also has an update, but I'm going to just leave it as is for now. I hate to update it and then it didn't work. So now we go to the compare buttons right here and we just hit compare. And what we want to pay attention to is this guy over here. There are no comparison colors except for the start date, report start date, and end date. So in Flow2D, we just tag this to today's date. You need to be careful if you are using a time series data or a tide, or you need to tie this to real-time rainfall or anything like that. That date needs to match your real-time rainfall date, or that date needs to match your tide date or your time series date. It needs to match the dates in those other data sets. Otherwise, you can just leave it like this because we just, for a design storm, you don't really care about your start date. You're just starting at 0 time 0 date. It doesn't really have a date. So you can just leave it as is. Okay. And these two are fine. We don't need to fix anything. So I'm going to close those. And then we'll do the next one, swimflow.dot. And this is the table that we rebuilt is this one. And this is the table that we imported. Let's just click that. You can see that there's no comparison, or excuse me, no differences. If the data that you import has doesn't have decimal places, because you actually save space by not writing these decimal places, but Flow2D is going to put those in. So just be aware that your comparison is going to be a little bit harder if that's the case. No changes, and swim out F, and no changes, close. So you can see that that import-export process works really well, and that storm drain conversion process works really well. Also, if you're doing a brand new project because you need to build a storm drain from an INP, you kind of work through the same process, except instead of joining, you won't have any data in these guys. So you'll be building this into the layers that were imported for the INP. You'll just be building this data into those layers. So that's a whole different can of worms. We're not going to talk about that in this video. So if you want to do something like that, contact me through my contact page and I can help you do that. It's pretty simple. Okay, so I will stop the recording here and this should be posted to YouTube.